this is a continuation of a conversation we started in June in Developers Day. And I think it's important to acknowledge that, we have also the need to address the certain actors that deal with network automation, which are people worry more on how the systems are running, how do they performance, and how we can actually be able to run them better, correct? So as we mentioned, this is a continuation of that conversation that we started back in June in Stockholm. And of course, we're going to be continuing this conversation about how do we monitor the automation stack. And I think one of the key things is we're going to give some updates on what we've been working in the last 6 months, but also give a preview of what we can expect for June. It is clear that, as we discussed, that the network automation is now central for our success. And because of that, we need to keep monitoring the performance of our systems. We also going to be discussing, as we see the greatest and latest features in the different tools, that we are getting better in terms of memory footprints, in terms of transactional support. So we have also to be sure that we have infrastructure to measure this progress and to make sure that we address the need of our customers. Because what they want, and as we're moving into self-service automation, is the need to always be on, the need to be faster than ever, so we don't wait for network as a service, but also the need to accommodate different type of customers that are going to be using network automation. Now, one of the new things that we're going to be discussed today is how can we actually connect network automation to that autonomous journey that was discussed by Daniele, correct? How can we actually connect network automation performance, network automation changes to actually the AI capabilities and the autonomous network journeys that we discussed from the network itself. So to do that, we're going to be tapping into a great ecosystem. And again, this is something we saw in June, and I encourage everybody to look at that recording. But basically, there's a key development in the cloud ecosystem that's called OpenTelemetry. So OpenTelemetry, it's a set of functionality. Yes, it's one standard. It's a protocol that allow us to actually transmit from systems what we call melt. What we mean by melt is metrics, events, logs, and traces. But also it's a collection platform that is able to take data from different systems and then send data to different backends. So in a way, we are decoupling how do we create the data to how we analyze the data, and creating this lingua franca between different systems and different sources, maybe hardware, or maybe operating system, maybe applications like NSO, or could even be telemetry from the network, and pushing that into backend to create end-to-end use cases. Now, as we discuss OpenTelemetry, it has the word telemetry on it. And we know it's always been the case where we can confuse a little bit on, hey, I'm doing telemetry in my network with things like OpenConfig, correct? Taking data out of the routers, the switches, and actually pushing that, for example, to Crosswalk, or using some open source tools such as Telegraph to create dashboards and replacing SNMP. Now, OpenTelemetry has certain overlap with OpenConfig in a sense that it can also be used for events and metrics, but there are different standards right now, correct? One of the key things is that both of them are on top of gRPC, but in a way they are different, and what they're trying to achieve is a little bit different. However, what we've seen in the last 6 months is by using things like collectors there is today available infrastructure that can translate between the two. So I can actually take OpenConfig data from the devices and push it using the OpenConfig collector into an OpenTelemetry environment, such as the ones we're going to see here on the AIOps. So this convergence between taking network data using OpenConfig, correct, and pushing that into an backend system or an AIOps system such as a Splunk, why not? Let's mention it. Using OpenTelemetry is a key factor, because using OpenTelemetry, what we've seen is that it reduces the need of integration and the cost of integration, where integration is one of the big barriers for the autonomous network that was mentioned by Daniele. So using OpenTelemetry massively will allow us to decrease this integration cost and actually being able to converge in a common data platform. Now, we showed in June a very nice demo on how we could use OpenTelemetry in NSO and some of the capabilities we have developed in NSO. In particularly, if you go to your NSO download site, you're going to find a new package that's called the the Observability Exported, which is a tool in NSO that allows us to take NSO data, so NSO telemetry, NSO traces, NSO metrics, and export that using OpenTelemetry. So by using this exported in this demo, we were able to take a network and actually export, yes, from NSO towards the OpenTelemetry collector. But also we can imagine that NSO is not working standalone in your network. You could have also other set of tools in your full stack. So you could have like a web service portal. So the customer may be connected using a telephone application, or maybe connected using your portal. So it's important that all this stack, all your OSS stack, you can export the data using the OTLP protocol, so this OpenTelemetry protocol. And every time an API call is done in your stack, there's a trace, there's an ID, there's a UUID that is transmitted in a way that the collector and the backend systems can actually correlate the data and understand that a given VPN connection was due to a customer trying to push and create a change, or that could be a migration that was happening, or it could be actually something that the operator started. So this sort of understanding of what is the transaction that is happening in your stack is something that OpenTelemetry will allow you by doing this context matching and the push of this, what we call trace ID, which is an ID that is pushed all over your stack. Now, not only that, with OpenTelemetry, I'm also able to export the data regarding the infrastructure that you are sitting. So if it is a Linux or if it's a container, however you are running NSO, you can now also correlate the information from the actual performance of your automation stack with the backend systems and the backend operating system that is running it. Now, which are those backend systems? And as we saw in the different demos over the years, we have some open source tools that can take this OpenTelemetry data, but we also have some commercial tools that can take this OpenTelemetry data and actually allow us to create more complex use case. These are the tools that are in the, creating a lot of what we call AIOps capabilities, a lot of IT management capabilities. So until June, we were really focusing on monitoring this performance, the performance of the IT automation stack, where you can see here that what we are creating based on these traces, and in this case is the Splunk Observability Cloud, which is a special branch of the Splunk toolset that allow us to understand applications performance. So in this case, you can see very clearly that we have a map that reproduces the performance from the web client, the cell phone client, to the web application, to the NSO server. So we can really understand how transactional is working. We can monitor NSO performance. We can also get ourselves in one single transaction and understand everything that is happening, correct? Every single call that is done to NSO, but also every single call that is happening all the way up to the stack. So it looks to me that we have everything that we need to create way more powerful analytics use cases. Because now, if I know that there is a change in the network created by NSO, and I know that that change was given by a customer change, we know that still 80% of the use cases of faults in the network are due to changes and configuration changes. So now with this technology, I can match a configuration change thanks to the trace ID all the way down to the customer doing a change in the portal, or to an operator doing a change in the migration tool of your choice. So that's exactly the new things. That's what we've been working in the last couple of months. Because when we were in Stockholm back in June, one of the key questions we asked the customer was what are you using to monitor NSO? And one of the tools that came on top was a Splunk Enterprise Platform. So this is different than what we just saw as an APM platform. This is a platform that monitors everything. Basically, it's a data platform that can take any input from the network. It can be syslog, but one of the things we can show you and we can demonstrate is that it can also take telemetry from the network. It can take device topology, device inventory, device alerts. It can connect to provide the connectivity assurance and actually get also SLA alerts from the network. And now we can also export, thanks to OpenTelemetry, NSO traces and metrics. So now you can use the same platform that you have, but instead of running it only with syslog, you can take OpenTelemetry data, export it from NSO to the platform, and connect that to data that you're getting from the platform, from the different networks. Now, what are the possible use cases that you can implement? Pretty much the span of use cases is infinite. You're gonna have You can do end-to-end troubleshooting, kind of like dashboards that troubleshoot the network and your automation stack in a single view. You can also use some AI ML toolkits to provide you forecasting, prediction, outlier, clustering, and we're going to see that back in June. But the last point is where I wanted to focus is about root cause analysis and event management. So as I told you before, 80% of the problems in the network are caused by configuration changes. So it's very important that we understand that there's something wrong in the network, and something wrong could be obvious, like an interface that goes down, but it could be less obvious, like a flapping that is happening, something that we need to actually use AI to actually be able to interpret it and something going wrong. And what we want to do when we do root cause analysis is not only to understand that there was a configuration change, we want to understand what was that configuration change, who did it, and actually where was it pushed in the first place in my provisioning stack. Was the customer via the self-service portal, or was it a migration on the operator, et cetera, et cetera? And thanks to this integration that we've done with NSO and the Splunk enterprise platform, we can use the Splunk ITSI application to actually allow us to do this. I just mentioned Splunk, but clearly you can use any of the possible AIOps platforms, and this is also enabled by OpenTelemetry, because the use of OpenTelemetry is pretty much universal today. Now we have documented the NSO, Splunk Enterprise, and Splunk Cloud integrations. That's available in the link that you find in the chat room. And the outcome that you're going to have is pretty much an outcome where you're going to see what we call AIOps episodes. So these episodes are basically a clustering. We are going to be basically clustering NSO with the network events. We're going to reduce all the noise that it may happen as event gets repeated and sent. So we're going to be clustering the SNMP, the telemetry data in a single possible event, and actually provide you recommendations using LLM on what are the possible changes and the possible solution to the problem. So you can see a full, pretty much generic closed loop use case using on one side network data, configuration data, and of course the AI capabilities. Now, how this looks in a real example. So what you're going to have is an incident caused by configuration change. This could be a simple event such as shutting down an interface, or it could be a more complex event that you may require AI. You may require using what we call outlier detector, like a flapping, a BGP interface that is not misbehaving. That will create an alert, correct? That will probably create an alert from the device. It could be an alert from the controller, as Crosswalk as we've seen, and it may have an impact on service health. So we have also service Crosswalk giving us a service health alert, where actually that issue in the network is affecting your services, and actually may be affecting, and you may be having packet loss in your services. And that's something we're going to receive from provider connectivity assurance using the SLA impact. So we are able inside this ITSI application Splunk to do the correlation from the receiving the network changes and the configuration changes using OpenTelemetry, the network state and the services, and being able to correlate that, create a root cause, and pointing to what was the actual configuration change that created this problem, and recommending you a fix, where this fix can be a service redeploy or can be a rollback of a configuration if you're using NSO, and allow you then the network to be back in and provide you with the full green, all okay. So this is an existing demo that we're going to be showing to the customer who join us at Cisco Live and of course in Stockholm. So for the matter of time, we're not going to have it today, but I promise you for the next time. But definitely this is the area that we're working on. OpenTelemetry, not only as a way to monitor, yes, the automation stack, we've done it, it's there, we're getting more features, but also enabling OpenTelemetry as an enabler to reduce the integration costs and allow you to integrate automation into that autonomous network journey, which is very important to allow us to create all of these very complex use cases, because remember, 80% of the problems in the network still are caused by configuration changes. So just to conclude today, so there's changes in the expectation from the automation. Not only, we are, people want not only that you can create scripts and being able to automate tasks. It has to be always on. It has to perform, and now it also has to help in the overall story to help operations and provide that enhanced business value. And OpenTelemetry is this opportunity in this fast move to tap into this fast moving APM environment, but also to reduce those integration costs, correct? So a single API that allows us to integrate. And with the NSO observability exporter, we can actually tap in whatever ecosystem you have that use OpenTelemetry standards. And I think one of the call for action that I always tell you is please talk to your IT teams, please implement and insert the OpenTelemetry, the observability exported in your systems, and start monitoring the performance of your automation. And of course, tap now into the new tools and the new world with AIOps and autonomous networks. So with that, Omar, I think we can cover my session. I think I was just right in time. Correct?
Yeah, you get an award for actually running a little bit under. So thank you for that. The production team is always appreciative. So a couple of things. So this look really cool. If someone says, "Hey, yeah, that looks like something I want to play with," how easy or how difficult is this to get started? You said there's a package we can download, but if you've never played with any OpenTelemetry, where do I go next?
Exactly. So that's why I put the link, Omar, because
Okay.
of course we have the recordings, but actually we took the work to actually document step by step. There is also in that link a GitHub pushed, so there's some examples there and the example of the demo in that GitHub, and that documentation, some of them allows you for the open source side, but also we included the Splunk integration because we've seen a lot of our customers using already Splunk. So in most cases they integrate with Syslog, but now they can also integrate with OpenTelemetry, which provides a number of additional data and additional features to the Syslog integration.
Cool, thanks. What other, so this gives you a good foundation in terms of basic integration. Where do you go next with this? Is there additional use cases that you think you can build off these integrations, or would you look at adding other types of integration into this?
Yeah. So one of the key things that we are, that when you have this sort of, of course you have the network integrations. These integrations will allow you, as I said, to tie automation with your network issues, but also you can tie that to your change management and ticketing systems or with your CRM. So basically, when you see changes in the network, you can understand, okay, this is the number of changes that are happening, but what about the tickets that I'm creating? Is that correlated also? Is the tickets that I'm creating for a service correlated with changes that has been done? So you can have as another source of data in this analytics tool. Also, you can integrate your ticketing systems like Remedy or ServiceNow, and now you can provide you in that root cause actually to understand that there's tickets coming from a given service, and that is connected, is the service healthy or not, but you can also connect in that analytics if there's any change done in that service in the last 2 days, correct? So then maybe you don't need a lot of machine learning to understand that, but it's very important to have this analytics tool that can correlate between those systems, correct? Yes, the customer is complaining. Yes, the service is healthy or unhealthy. Yes, there's been changes done, and where those changes were done, by who? Was it the customer requesting the change, or was it the migration of the operation? So OpenTelemetry allows you not only to easy the integrations, but because of this trace ID, it allows you to tie the different systems and to have a full view of the transaction that happened, where it was originated, and why this change happened in the network.
Okay, I mean that makes sense. So you said this early on. When you look, when I see telemetry, I think about a very specific set of device activity types of thing. But what you're really saying is look at telemetry more as an event stream of multiple things. Change tickets, could be signals from your assurance, and those kinds of things, and being able to aggregate those and use something like Splunk or something else to do the correlations, find patterns. those sorts of things.
It is really a revolution on the IT stack that is, just started, I think.
Cool, that's cool. I mean, I think that's a key thing to look at, telemetry in a much wider perspective in terms of just tracking things that are going on. And then it is a great example, I think, for Splunk in terms of taking those disparate data streams and figuring out what the patterns or what the connections are. Cool, thank you. So can I expect an update in Stockholm as to kind of the next version of this? Cool. We'll stand
More use
with
case, more integrations are coming your way.